Hello everyone. Today we are getting into our last section of Chapter 8, and this one's called 8.6, Compare Linear, Quadratic, and Exponential Functions. So we started the year learning everything to know about linear. At the beginning of this semester we learned about exponential, and we've been talking about quadratic functions for the last couple of weeks. And now we're going to compare all those properties together. So for this first video, we're going to compare their format when they are in table form. So if you recall, a linear function is when you have a constant change in x corresponds to a constant change in y. So if x goes up by 1, it always goes up by 1, and if y goes up by 3, it's always going up by 3. In an exponential function, however, the consecutive y values have a common ratio. So if you recall, that means y is either being multiplied or divided by the same number. So linear was when it was being added and subtracted. Exponential is when it's being multiplied or divided. Now for a quadratic function, this one's going to look a little bit different. In a quadratic function, the constant change happens at the second difference, not the first. Okay, so what do I mean by that? So looking at this example, here, my x is always going up by 1. That's always going to be the case. And then now, for my y's, I see at the first difference, from 0 to 1, I add 1. From 1 to 4, I add 3. From 4 to 9, I add 5. From 9 to 16, I add 7. So those aren't the same. But when I go and take the difference again, from 1 to 3, I add 2. From 3 to 5, I add 2. From 5 to 7, I add 2. And I see that the second difference is the same. And so that is going to be a quadratic function. So let's look at some examples. So looking at number 1, I'm going to look at my x's first. I see it's just adding 1 every time. And now looking at the y's, I like to start to see what am I adding and subtracting each time. So to get from -4 to -3, I add 1. To get from -3 to 0, I have to add 3, because -3 plus 3 equals 0. To get from 0 to 5, I add 5. 5 to 12, I add 7. And then from 12 to 21, I add 9. Another way you can find those numbers is if you take the second number and subtract the first. So 21 minus 12, and you get 9. So I see these numbers aren't the same, so this isn't linear. But I need to see maybe the second difference is the same. So to get from 1 to 3, I add 2. From 3 to 5, I add 2. 5 to 7, and 7 to 9. So I see this is the same, and so that means that this is quadratic. Okay, let's try another one. So here my x's again are going up by 1. For my y's, to get from 2 to 6, I add 4. 6 to 10, I add 4. 4. 14 to 18. 18 to 22. I see this is all the same. I see that my x's all go up by 1. And so when it's the constant with your x and your y, that means that this one is going to be linear. Okay, let's try number 3. So for number 3, I see I'm adding 1, and so on. From 2 to 4, I add 2. From 4 to 8, I add 4, add 8, add 16. And then when I go to the second difference, I see I add 2, 4, it's not the same. So if you get to this spot where it's not going to be either, then you probably want to see whether it's exponential. So I'm looking to see, okay, is there a number I'm multiplying by each time? And I see to get from 2 to 4, I multiply by 2. 4 times 2 is equal to 8. 8 times 2 is equal to 16. 16 times 2 is equal to 32. And so on. And so here, since I'm multiplying by the same number each time, it's going to be exponential. Another clue in that's going to be exponential is the fact that I got big so quickly. I started at 2, but then I ended at 64. When that happens, it's most likely going to be exponential. Okay, go ahead and pause the video and try number 4 and 5. Be careful number 4, it's a little tricky. So the answer you should have gotten here was quadratic for number 5. Number 4, it looked like it was going to be quadratic, but actually wasn't quite there, so this one was actually going to be none.